This is Sudheer, working as an assistant professor in Department of Civil Engineering at Institute of Aeronautical Engineering, Dundigal, Hyderabad. Then coming to the basic properties, how we can define a liquid. As we have discussed that we are mainly confining to the liquids. Now from this point onwards, we are discussing in detail about the liquids and their properties and their behavior either at the rest position or in the moving position. Now coming to the liquids properties and all, we can say that as we had known that it is a fluid is a substance that is continually deformed under the action of applied shear stress or any other external force, and it has no definite shape or no definite volume, but occupies or but conforms to the shape of the vessel or given object. So if you are going to see about the basic properties such as the pressure, temperature, volume, mass, acceleration, velocity, or all the things which we can say like hydraulic properties of the typical liquids, where it is possessed by almost all the types of the liquids. And coming to the another classification of the fluids based on confining to the liquids, basically the liquids are being classified as either ideal fluids or real fluids. So the ideal fluids are hypothetical fluids or which are imaginary, and hence we are always seeing the case of the real fluids, so which may constitute of different types of the losses that we are going to discuss in the further on classes. Again, where we are going to discuss about the analysis part, which will be an interesting one. Then coming to the properties, as we are discussing in detail, basically these are classified into two categories, like such as intensive and as well as extensive. So how do you classify them? So intensive properties are those that are independent on mass of the system, such as like temperature, boiling point, and are the examples of the intensive properties. And coming to the extrinsic properties or extrinsic properties, they are completely depend upon the size or extent of the system, like volume, area of the cross section of the object, and the area of the cross section under consideration. All these are all the examples of the extensive properties. Now we are going to see some of the examples here, as we had seen that the first category contains the examples of intensive properties which does not depend upon the mass. Like for example, if you take the boiling point, color, temperature, these are all completely independent of the mass. Coming to the extensive properties, where it is depending upon the size and extent, where we can see like volume and as well as the mass and size or length of the object under consideration, or these are all the examples of the extensive properties. So here all the properties are broadly classified under these two categories. Now in detail, we are going to discuss one by one all these properties. So the basic important property that is called as a mass density, which is very widely used in the application part with respect to our examples. Now let us define what is meant by mass density and how we are going to calculate that value. So basically it is defined as the ratio of the mass of the fluid corresponding to its volume, so which can be expressed as m by v. So generally it is going to be denoted with rho, which is called as a mass density, but majority of the textbooks are going to simply call it as a density, which also refers to as a mass density. But in my opinion, since as there are some other types of the density, that is also a weight density, so I suggest you to please be specific whenever we are going to use the term density, whether it is a mass density and as well as the weight density, since the mass and weight are not equal. So therefore, in order to be specific, the mass density is the ratio of the mass to the volume of the given object, and its units are being expressed as kg per meter cube, and in the terms of dimensional quantities such as m, l, t, there it is going to be expressed as m to the power of 1 and l to the power of -3. And the values of the mass densities are going to be varied with respect to the different types of the liquids or as well as the gases also. So basically we are going to take water is having a unit value of the mass density as 1000 kilogram per meter cube, and mercury as 13,546 kilogram per meter cube, and air as 1.23 kilogram per meter cube, and oil as 800 kilogram per meter cube. But most of the cases we will not see that water will not, the value of the mass density of the water will not be given in our problems, that we need to assume that. But apart from the water, all the other types of the liquids for which under analysis part will be given either directly or indirectly. So we need to remember these basic formulas, and thereby we are going to determine those the required parameters with the given values in the problem. Next one is about the weight density. So weight density is also called as a specific weight, which is defined as the ratio of the weight by volume. That is the weight of the liquid by volume of the object. So it is the ratio of weight and volume. So that's what I told you, that since it is also looking similar to that of the mass density, it is suggested that to be specific whether it is a mass density or weight density perfectly, because as we know that weight and mass are not being the same, and its units are being expressed in SI system or Newton per meter cube. Of course, in different types of the system, we are going to express in different types of the units, maybe in MK system or in SI system or in CGS system. Basically, in all the problems, whatever we are going to solve, it will be in SI system only. And its dimensions are going to be expressed in terms of MLT or m to the power of 1, L to the power of -2, and t to the power of -2. Then its values for which are required for the analysis is given as like water 9814 Newton per meter cube, and mercury it is 1,32,943 Newton per meter cube, air 12.07 Newton per meter cube, and oil 7851 Newton per meter cube. But it is suggested again here that in the case of the mass density as well as in the case of weight density, the standard values or the standard liquid which we are going to take it as a pure distilled water, those values are going to be remembered at each and every step of where we are going to solve the problems. Whenever we are going to solve the problems, it will be coming under the case. Next, the combination of the mass density and as well as the weight density can be considered as a specific gravity. So it is also called as a relative density. See here, we are going to use the term relative density because we are going to take the ratios of two densities. Means the density of two objects, whether in terms of the mass density or in terms of the weight density, we are going to take, and hence we are going to calculate or we are going to call it as a relative density, which is defined as the ratio of mass density of the given substance to the mass density of the standard liquid. See here we are going to take two objects, or I mean to be strictly speaking, two liquids. One is the density of the object, or that is the mass density of the object which is known, and the other one is the mass density of the object for which it has been given. So here the mass density of the standard liquid is always pure distilled water at 4 degrees centigrade. Pure distilled water at 4 degrees centigrade, and whose value is going to be considered as 1000 kilogram per meter cube. 1000 kilogram per meter cube. Now the mass density of the given substance, maybe it may be an oil, or it may be an some other liquid or petrol, diesel, or some whatever the given type of the substance it has been there. So therefore we are going to consider that given liquid under the problem or under consideration. But in the denominator, the mass density for the standard liquid is always a constant. Okay. In other words, we can say that it may be also defined as the ratio of weight density of the given substance to the weight density of the standard liquid. So here, in both the cases, we are going to take the densities, either it is a mass density or weight density, and hence its units are going to be taken as none. Means it has no units, since on the numerator and the denominator is having the same quantities. Therefore we are going to get a constant value which has no units. For example, it might be 1. Okay, so and therefore in terms of MLT we can express like m to the power of 0, L to the power of 0, and t to the power of 0 only. Next, the typical values for which we need to remember, like for water, that is always 1, and for mercury 13.5. And here we need to remember that mercury also, as most of the cases, because when we are going to do the laboratory part, we may come across with the different types of the liquids like mercury or carbon tetrachloride or some other type of the liquids. So here, if you are going to remember the specific gravities, so that it will be very easy for our calculation. And for oil, how do you, the specific gravity is going to be 0.8. So here, this is the very important part which we need to focus on this. The last one is about the specific volume, which is defined as the reciprocal of the mass density. As we know that mass density is mass per unit volume, and here we can say that volume per mass. So therefore the units are also going to be taken as a reciprocal of the mass density, that is meter cube per kilogram, and it is mathematically expressed as 1 by rho.
Like, share and subscribe. Hit the bell icon for more updates.